Hey class. So today we're going to be talking, yesterday we talked about limits, but now we're going to talk about both the left and right limit. So this is my left, this is my right. So in the video it will be this left, that right. Point is, what's the point of figuring out left and right limits? Isn't every single limit going to be the same? That's not always true. But before we get into that, let's write the definition of what it means to have a left limit or a right limit. So the definition is, we say that as the limit as x approaches a from the left, f of x is equal to L. So we write the left hand limit of f of x as x approaches a for the limit of f of x as x approaches a from the left is equal to L. Okay, now what does this mean? What does this garbage mean anyway? So what we know from the definition from limit means is that when we get really close to the value of a letter, or of a value I should say, it will spit out an output depending on how close we get to the function. But what this is saying specifically, this notation where you see this little a to the negative, it's not a to the power, it's just a notation from the left. Now, what am I talking about from the left? No, I'm not trying to get political here. The point is that this is just a notation, because we know that if you have the negative on the left side of a, it'd be negative a. We're not talking about negative a. This is a pretty confusing notation, but when we say from the left, we're talking about it based off a graph. So when we talk about the negative, we're talking about, let me just erase this real quick. When we're talking about from the left, we're talking about the negative side of a graph. So let's say we just had some random function, I don't know, some line that just goes, but it stops here, right? X, Y, 0, and this is at, I don't know, 1, 2, 3. Let's say, we'll put the 3 right here. So here's the thing. We'll call this g of x, which is y. So this is 2, this is 1. So 0, 1, 2, 3, right? So what this is saying here, right? G of x. Well, when we take the limit as x approaches let's say 1, 2, as x approaches 2 from the left, right? For g of x, that means what's my y? What's the output that's going to spit up? We notice that it's getting closer and closer to 3, but it stops here at 2. So then we know that the output here is going to be 3 because it's getting pretty close to 3. It's not touching 3, it's just like right under. There's like this little asymptote almost right there. So visually what we're talking about is when we're saying from the left, we're talking about from the negative side of the numbers, from the left here. That's why it's called from the left. So understand that this is just a notation. Now, you're probably wondering, what does it mean now? How do we define something from the right? Well, we would take the limit as x approaches 2 from the right by adding a plus sign for the same function. So then you look at values from the right, and we'll just make this, I don't know, just add something, I don't know. The point is, you look at values from the right of the number that you have here. Because if you notice, we looked at the numbers from the left, from 2, we can look at it from here, it's approaching 3, and this is approaching 2 from the right, because I just made it go down. So now there's a question though that some people might assume that if it's true on the left, is it always going to be true on the right? And that's my answer to that is no. It's not always the case where it's guaranteed where one side will be the same as the right side. So let me explain. Let me give you an example of what I'm talking about. And generally, when you're doing limits from the left and right, they're mainly visual. They're not really computations, well, that I know of, but if they are computations, I would like to see some. But let's say I gave you this example, right? Let's say I gave you this graph. X, Y, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 5. 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 5. Okay, and the graph looks like this, where again it's similar to the last one where this is 3, the line is going right under 3, but we stop at 2, but at 2 down here it is also opened, but there's a dot here filled at 5, and there's also an open circle here as well. Now, what is this saying? There's a lot of holes in this, so there's a lot of holes in the argument. The point that I'm trying to make is that this is what your example is for g of x here, and that you're asked to find the limit as x approaches 2 from the left, g of x will be the limit as x approaches 2 from the right of g of x. So we know, again, by the same rule that we were doing before, we checked it from the left of 2 here. So we're checking, and it's getting pretty close to 3 for the y values. So we're trying to think of it this way. When you're doing the limit, you're getting an output of the y-axis. So that's why when we're getting close to 2 from the left, it's approaching 3. However, when we're approaching the limit from the left, we're noticing it's actually getting very close to 1 from the right. So that means this is 1. Now here's the thing. Well, I don't have to write it out, I can just say it. If two limits do not match up at all, they're not the same, then the limit for this function does not exist at all. So you could take the limit of this function or whatever this thing is, because we didn't label what this thing is, but the point is that if you were to try to find the limit of this thing, it doesn't exist because you check the left and the right side, they don't match up, then it doesn't exist. If they match up the exact same number, then it does exist. So what if I told you to find the limit as x approaches 5 from the left of g of x? So we have 5 here, so let's look at from here. It's approaching, well, I kind of made this a little bit wrong. I actually wanted to approach 2. So yeah, it's about there from 2. It's about approaching 2, and it's kind of like skidding off, if you notice that. So it's approaching 2 here, and same goes for the limit as x approaches 5 from the right. We can see if you approach it from the right side of this function, it's also 2. So for a and b, the limit does not exist, but from c and d, the limit indeed exists. So let's real quick write the definition so you guys have it for the limits. In general, when you're doing limits, well, left and right limits, the limit as x approaches a, f of x equals L, we'll put exists if and only if the limit as x approaches a from the left, f of x equals to L, and the limit as x approaches a from the right of f of x equals L as well. When we say L, we're just talking about the output. The output is the same thing. It should be the exact same thing. We shouldn't have anything different. And if we do, we have a problem. So that's the idea, concept of let's see, left hand and right hand limits. Again, this is my left, this is my right. So again, left, right. The point that I'm trying to say is that left and right hand limits they're somewhat easy to understand in the beginning, but it can get a little bit convoluted if we have harder examples. But I wanted to just break down what it is to understand limits a little bit better. So this has been Absolute 5. Be sure to like, share, and subscribe to our channel. Be sure, and if you would like to get more notifications from me, if you need more help with math, be sure to hit that bell button next to the subscribe button. And I will see you guys tomorrow for another lesson, or if not a lesson, another video. And that I want to say thank you for watching the video. And math is infinite, and because there are infinitely many possibilities.